Okay, for this next video, what we're going to do is we are going to learn how to use this standard normal table. Okay, so first let me introduce what the standard normal distribution is. Okay, so all this is it is like a normal distribution, okay, except along the bottom you have z-scores. So the center will be 0, and you're going to have 1, 2, 3 above, and -1, -2, -3 below. Okay, and so these are z-scores down here. So it's usually called the standard normal distribution. Sometimes it's called the z distribution. Okay, so oftentimes the standard normal table, this is called the z table. Okay, and first thing that's important here is what we're going to say is the area underneath this curve is equal to 1. So the total area under the curve is equal to 1, and you want to think about that kind of like a probability distribution. When we did the discrete probability distributions here, if you remember, we had a distribution like this. We had some values and their probabilities. When you add up the probabilities, they added up to 1, right? Okay, well that's like this. If you add up all the area, the total area is equal to 1. Okay, and what we saw before is like between -1 and 1, when we talked about that, this area between there, that was like 0.6826, right? So I could write, let me write it up here so you can see, 0.6826, which you move the decimal point over, that's like 68.26% of the area. And we talked about between one standard deviation on either side of the mean is 68% of the area. Maybe I can zoom in a little bit. Let me let it focus here. There we go. Okay. And so the area here is actually like the decimal form of the percent. It's like a 4-digit decimal number, and the areas here are like right in this part of our table. And it's a 4-digit decimal number, and it is the decimal form of like the percent of the area that's underneath the curve. What we're going to do is we're going to look up these z-scores along the bottom. We're going to look those up on the table, and it'll give us an area. Okay, so now let me give you an example. So let's say I'm going to look up -1.34. So our z-scores will always be to 2 decimal, or the z-score will have 2 decimal places here. It'll be to the hundredths place. Okay, and when you put these on the curve, when you do these, I'm going to have you, well, I would like you to draw out curves like this. You're going to be doing them online, so but when you draw out the curve, go ahead and put this underneath the curve and make it kind of realistic. It doesn't have to be perfect, but the z-scores go like -1, -2, -3, 1, 2, 3. So -1.34 would be a little further out, but not way out. Okay? And what we'll do is we'll look up this on the table, and what it's going to give us is it's going to give us the area that lies below that. Okay? And so one thing that you have to understand when you use the table is the table always gives area to the left of the z-score. That is so important. Okay, so from the z-score on down, and it just keeps going on and on, the table will always give me the area that lies to the left of, or we could say below that z-score. Okay? And so the question is, how do I look that z-score up on the table? Okay, well, what I'm going to do here on the table, I'm going to first look it up on the negative side. So if you look, this is the negative side, because these are all negative z-scores here. Also, when you look at the table, here's 0, or when you look at the diagram here, 0's in the center, and what you got are z-values that are to the left of 0. Okay, also the area here below these z-values are all less than a half, because the area underneath 1/2, or the area underneath 0 would be 1/2 or 0.5. So all these areas are less than a half. And then on here, this is the positive side. So these are the z-scores, and they're all positive, and 0 is in the center here, right? And our z-values are to the right of, or to the left of 0 here. And so the table will always give you the area to the left of the z-score, so all these areas are always going to be bigger than a half. So all the area here is bigger than 0.5. Okay? So the way that I look this up on the table is I'm going to look up negative 1.3 down here, and then the hundredths place is 0.4, or 0.4, and I'm going to look that up along the top. So let me show you on here. So it's negative 1.34. So I'm going to take this part and the negative 1.3, and I'm going to look that up down here till I get to negative 1.3. And then this hundredths place here, that's the hundredths place. I looked that up. It's a 4, so I'm going to look up 0.04, so it puts the 4 in the hundredths place. Okay? And where this row and this column intersect, you get a 4-digit decimal number. So it looks like this. I'm going to look up negative 1.3, 0.04, and where this and this intersect, I get this 4-digit decimal number. It is 0.0901. So if you have a table, you might want to look it up and make sure you're doing it right and you're getting the same number here. Okay, and so that's going to be this area. Like I said, the table always gives you the area here on the table. It's always the area below the z-score, or to the left of that z-score. So I get this area, and if I change it to a percentage, it would be this. It's just a little over 9% of the area. So what that would mean is that the percentage of the population that has a z-score less than negative 1.34 would be like 9.01%. Or you can think of it as the probability of randomly selecting an observation from the population that has a z-score less than negative 1.34 would be 0.0901. Okay? So let me do one more here just to make sure we got it. This time, maybe what I'll do is I will pick a number way up here, like maybe 2.76. So again, I make it realistic here. This one, 2.76, is closer to 3, so it's going to be real far, further out in the distribution. And when I look up this z-score, I'm going to get all the area to the left of it. Remember, the table always gives you the area from the z-score all the way down. Okay, so now I'm looking this up on the positive side of the table. Okay, so I'm going to take my table, flip it over to the positive side, and then I'm going to look down here till I get to 2.7 over to 0.06. So it'd be like this. I'm going to look down till I get to like 2.7 there near the bottom of the table. I'm going to look over here till I get to like 0.06. Okay, and where this row and this column intersect, I get a 4-digit decimal number. Okay, so 2.7, 0.06, and these two intersect right here. I get 0.9971. 0.9971. Okay, and so that's this area over here, 0.9971. Okay, and you can think of that as like 99.71%. And this makes sense, right? Because pretty much all of the area is below this particular z-score, 99.71% of the area. Okay, so so my son just came down. Zachariah, you need to go upstairs. You're interrupting, okay? So you can grab the iPad. Sorry, excuse me. Okay, Zachariah, go ahead, take it up, but don't interrupt anymore. Okay, sorry about that. So that makes sense. You would get pretty much all of the area to the left. Okay, and one other thing. Let's say I wanted this area to the right of it, and that's just like a little smidget of area up above that. You can actually get that area by subtracting from 1. Okay, because it's a complementary probability. A z-score will either be below that value or above that value. It's one or the other, right? And so those are complementary events. The two add up to 100% of the area, or the two areas add up to 1. So I just take 1 minus 0.9971, and I get 0.0029. Okay, and that's like a fraction, right, of 1%. Just a real tiny smidget of area up above there. Okay, so that is how you use the table. And so on the next video, I'm going to show you how to use the standard normal table to look up probabilities. We'll call them z-score probabilities, and there's going to be 3 cases. So we will look at that next.